Now that the tutorial is finished, I would like to share my own personal class's data set. So this particular, it's the same spreadsheet, it's just saved for my class version. So you'll see the example case here. As we scroll down, we'll see different sets in there. As a teacher, you'll become familiar with what these clumps look like, and if there's errors in it, you can see what's going on. Just scanning through it, you see each is a piece of the puzzle. So there might be close to 20 in this set, and some of the data is not all that exciting when they're done, it builds up to a nice, interesting finish, because what happens is that when we go to the class data, every one of these graphs is then inputted onto this second sheet down here, the class graph. So when all those pieces are put together, we get something that looks like this. There's definitely a pattern in there. And in the last page on this worksheet, we have this image right here. This is a very famous image in this regards, in looking at the Doppler shifts, which turn into velocities relative to the Earth here, based on the galactic longitude, just like our map right here. So basically what we're doing is taking this actual observed data, and we're taking our model and seeing how well it overlays. So I just clicked on the image that got rid of the grid behind it. So if I just kind of click off uh, the image, then the data from the spreadsheet comes back in, and you can see that it overlays the galactic model, the actual data graph, quite well. Just quickly, in case you want a little extra information on this, uh, in this particular representation, the whiter or redder, it's almost like a radar map. The white and red indicates a more intense um, signal in that Doppler shift. And what the galactic astronomers do in this model here is they look for these intense regions and try to pick out the Milky Way arms out of this. In our model, there's an equal density of stars in all directions, so we're not going to see where there's going to be more hydrogen. And the more hydrogen is more intense, and the more intense is going to indicate where those spiral arms are. So if they see something along this line, they'll be able to map that as a spiral arm down through here, here, and then out here again. So that's the interpretation there. And if the class does a good job, then the data should fit reasonably well in that space.